Hello guys, welcome to Zip Code, and today we are looking at Hello guys, welcome to Zip Code, and today we are looking at another cup of code. We are talking all things junior Java developer interview. Wanna see like a couple of questions. We're gonna run through 10 questions. We don't want to make this super long. I wanna make sure that we go straight into the answers, the details, the experience, how you can basically ace your junior developer interview. And I hope this comes in very handy to ace you that particular job, that first job, that internship, or that junior role in actual fact, where you will basically secure yourself a good income and enjoy the perks of being a software developer and grow your long career. So without wasting any time, let's get right into it. One thing that I'd like to request is can you please do like and subscribe, and also share the videos if you find it very useful for other developers and other tech geeks that are looking into growing their careers. So that will be very helpful, not only to myself but also to the community that I basically create these tutorials and videos for. So let's get right into it. So the first question we'll be looking at is, what are the main features of Java? So typically you will get these to understand, the interviewer would want to understand your level of Java exposure and experiences if you have worked with some of these features, and you would basically have to go into a little bit more details in what you have been exposed to. So things like the platform independence, they want to know that you are aware of what capabilities Java has to offer, which is write once, run anywhere, which is basically allowing you the flexibility of single write and reuse, and that's essentially what Java offers. The next thing will be your object-oriented programming principles. So these are very detailed. You have 4 of them, and it could be your inheritance, your abstraction, encapsulation, your polymorphism. You would have to go deep into details on those and basically share more details. We do have a question on those, so you will see them, and I'll explain them later on. But essentially, if you understand your OOP and what those pillars stand for and what they mean, that will basically give them some sort of comfort into how vastly you understand the language and the fundamentals. And then the next one will be your automatic memory management, which you have a garbage collection process, which essentially cleans out memory or objects that are not in use. This is very quite common in interview questions, especially junior interviews. So it will definitely come along quite often in your, let's say, in their roles. But essentially, they would want to ask you some like tricky questions if you can call the garbage collection manually or trigger it whenever you see fit. Which the answer will definitely be yes, you can call the garbage collector to basically run and to clean some of your memory to allow resources on your application. And then the next one is multi-threading support. This is essentially your concurrency and things like that. So can you have multiple threads? Can you run some processes concurrently? And that's definitely a yes. And you'd want to share as much as you have over there. And also, it's not an issue to share or topics that you haven't been exposed to as much. And they would understand that if you have gracious interviewers that understand that you are at a beginner level, there are certain topics that you wouldn't have vast or that deep dive into, but obviously with exposure and experience you would gain more of those features or understand more of the features. And another thing you would have is security and the robustness of the language itself. So it offers different types of security, and you would basically in the security topic you would have mostly like in APIs, backend concerns, web services in terms of how do you authenticate users, how do you secure like a role-based access control, how do you set that up, how do you make sure that users don't get exposed to data that they're not supposed to see. So things like that you would have to then share accordingly. What is basic authentication? What certain level of security that you can put in place, like maybe if it's not your basic username password, you have like your SSL, you have token-based authentication, and these types of security measures are already available, and you can basically make use of those to secure your applications or your web services. And then the reach of APIs and libraries. Obviously, Java being open source, you are basically at the leisure of a lot of community developments that share a lot of APIs, a lot of libraries. So some of the stuff is already been developed. There's no need for you to reinvent the wheel. You basically reuse a lot of libraries that are available in the market for whatever feature that you are looking for. And that's essentially about it in terms of the features of Java. But you can go as more as you as comfortable as you see. But obviously you would have to share more details into those. Then going into the next question is, what is the difference between a JDK, JRE, and JVM? This is essentially to understand, to get your understanding of, do you know what tool is used for what situation, or when to use what tool within the Java framework, if I can call it that. So essentially, you would have a JDK, which is Java Development Kit, and you would have a JRE, which is a Java Runtime Environment. That is where you execute the artifact that is generated for deployment. So your jar, your wall, your end artifact, or the final artifact that is generated for deployment. And then you have your JVM, which is Java Virtual Machine, that then interprets the final artifact into an actual application that is an executable that a user can see and interact with, or that can basically be called by another application and things like that. So JDK includes the GRE, plus the development tools like the compiler, which is your JVAC. So the GRE, the reason why they include the GRE in the JDK is because when you, as a developer, you write your code, you essentially need to test your code. So you need to run the code, and for you to run the code, you need a runtime environment. So that's why the GRE comes along with that. And then GRE obviously contains libraries in JVM to run Java applications. So as I said, the JVM is the actual machine that runs the final application, and hence the GRE makes use of that. So JVM converts bytecode into machine code for execution. So this is where final product is then basically interactive and can run a few processes, or can now interact with the user in different formats. You have desktop, and you have web applications, or Java for whatever interface or device that you're developing for. So things like that, they come into play here with the JVM. And the next question is, what is the difference between equals to and the dot equals to in Java? And this comes a lot in interview questions, and you would have to don't get it confused. So the equals to checks the reference equality whether two objects point to the same memory location. So what this means is, do these two objects that I'm comparing basically point to the same instance? That is the essence of this equality sign, if you can call it that. However, the dot equals to checks the content equality, which is the values that that object contains. Are those values the same as the other object? So it doesn't check the instances, it checks the contents of those two objects. So equals to is, are these two guys pointing to the same instance, which is the same memory location. And then the other one is, okay, these two instances, what do they contain inside? That is the difference between equals to and the dot equals to check. So let's put this into so that I can show you. Let's go to maybe this DTO. One thing that I want to show you in the capabilities of Lombok, you would have over here, let's say you would have an at equals, you would have an equals and hash code. So these equals, not actually that one. There's add to string, right? Yes, that's the one. So add to string. So in a nutshell, if you have an, let's say this DTO, event payload DTO, if you have this payload and you have these two string, it will take these fields here and generate a two string of the values inside this object. So that content from the two string is the one that is checked to make sure that this DTO is the same as the next DTO that is being compared to. So it's basically using these two string if we can put it in simpler terms. So that is what is used here. That is what is used here on the dot equals to. Whereas here is just to say is DTO1 equals DTO2, and that's the comparator that is used for that case. And then if you continue, the next question is, what are the four pillars of object-oriented programming, essentially OOP? And again, as I mentioned, this will definitely come through. They would want to understand what's your understanding of the inheritance, encapsulation, abstraction, and polymorphism. So you can go as deep as you understand it and share as much of your experience using all of this in maybe your side project or practice projects and things like that, or portfolio project, if you can put it in better words. So encapsulation is hiding data using access modifiers. That's your private, public, protected. And again, they would definitely ask you these access modifiers, what do they mean? What do they stand for? And you would have to share your understanding of private, public, protected. What's the scope of exposure or availability in terms of when a field is private, when a field is public, when a field is protected, and you would have to share this. Essentially, this is Java fundamentals questionnaire when it comes to junior roles. So understanding all of these, what do they mean, the keywords, and the syntax in the language, if you understand those fundamentals, you're actually in a better position. And again, my request is, could you please like and subscribe if this is informative to you, if it's helpful, if you're preparing for an interview and you have any questions, please share them down below in the comments. I'll basically respond to those, share with you how you can navigate those questions, share with you how much detail you can go into answering those questions. But most importantly, please do like and subscribe. It really does help motivate for what I do and basically to continue doing more. And then let's continue to abstraction. So abstraction is hiding implementation details using abstract classes and interfaces. So here we are essentially saying the concrete implementations, we can basically abstract that using different methodologies, your abstract classes, your interfaces, and we can basically allow for our implementations to be under the hood or behind the scenes. So it's like driving a car. You pretty much care about starting the car and going to where you're going. Your concern is, does it have petrol? There's no maybe alarming lights on the dashboard and things like that. But we don't really care what happens in the engine. As long as it works, that's basically the abstraction, that the complexities of the engine running and how it functions, that has been far removed from the driver's reality of, I just get in the car and make sure that if I start it, it starts and there is no line that is flashing for concern. And if all of those are fine, then everything is in good order or in good shape. So that is abstraction in a nutshell with some example over there. So Inheritance is acquiring properties of a parent class. Um, so inheritance in let's put it in a situation where you have common features across different scenarios, but you want those um, let's say features to be shared across these different scenarios. You would then have inheritance where you inherit certain properties and basically use them in child properties. So like your think of it like your shapes. So you can have a shape superclass that then we basically creates or shares let's say common functionalities with its children. So a shape can have like let's say length or width or something like that. Let's say maybe a square or a rectangle, they have like a length and a width. So those are common features across a square and a rectangle. So you would have like one parent class, and then you'd have these two subclasses, and those subclasses can then inherit these properties from the superclass, which is called shape, and then they can basically use that according to their different implementations or the way that they are basically designed. So that is inheritance in a nutshell. So polymorphism is having multiple forms, method overloading, and method overriding. So polymorphism, you're gonna see this later on. There is a question on this where you basically have to differentiate between method overloading and method overriding, and we'll go into detail in that question. So stay tuned and let's continue. So what is the difference between an abstract class and an interface? So the difference here is um, features on the feature side, the methods. So an abstract class can have both abstract and concrete methods. What does this mean? It means an abstract class is just a method signature. An abstract method is a method signature, no implementation. And a concrete method is an entire method that does functionality, it has implementation, it can basically execute that code without that particular method being changed or modified in any shape. So it has concrete methods that can basically execute with basically the parameters provided and things like that. It will execute with that implementation. You wouldn't need to mess with those methods. And then on the other side, an interface only has abstract methods. So it's an interface with method signatures, and that's it. So that is before Java 8. Obviously, that's just a highlight. And then on the fields perspective, in an abstract class, you can have instance variables, whereas on an interface, you only have static and final variables. So an interface, what really is, anything that you give to an interface, it has to be static, and it basically doesn't consider dynamic behavior if you put it like that way, because the methods you have one method signature, and wherever you basically implement that interface, you have to follow or override those particular methods, and then the fields that you are expected to have available in an interface is only static and final variables, which means an interface has to know what is expected of it, and it can't be a dynamic value because it's a blueprint of what the concrete classes are going to look like or what they're going to expect. And that's essentially why it wants those static and final variables. Then on the constructor side, so abstract classes, you can instantiate an abstract class. You cannot instantiate an interface. So you cannot have constructors, and because you cannot have constructors for an interface, therefore you can't create an instance of an interface. Because remember, a class that has constructors, it means, so essentially a constructor is an entry point to a class. and that is what makes them also different. That an abstract class can have constructors, which means it does have an entry point. An interface does not have a constructor, which therefore means it doesn't have an entry point, therefore you can't create an instance for it. So I hope that was clear and pretty short. Moving on to the next one, what is the difference between ArrayList and LinkedList? Again, this will definitely come uh, quite often. You'll come across this even at different levels of software development interviews. It will definitely, excuse me, it will definitely come across. So let's see the difference. So ArrayList internally use a dynamic array to store the elements. So essentially, it uses an array, put that into perspective. But because the array is dynamic, which means whatever elements are added or removed, it manipulates the array internally, hence a dynamic array. The linked list internally uses a double linked list to store elements. And this introduces a different level of complexity, and you will see in just a few points why it does that. So let's move on to the next one. The manipulation with ArrayList is slow because it internally uses an array. So if any element is removed from the array, all the other elements have to be shifted in memory so that you can basically move the size of the array to accommodate the number of elements that are now in the array. And then the manipulation with linked list is faster than array list because it uses a double linked list. So no bit shifting is required in memory because it has node pointers, and that basically is why it's able to just use those node pointers to say element X has been removed. The node pointers have to be updated to point to the two connecting nodes, and that's about it. Whereas in an array, you have to move an entire set of objects or elements within the array to new indexes all together. So that's why you get that, and hence the double linked list has a sort of different complexity that it uses the node pointers to know that this is the link, this is your next link, or this is your previous link, and it basically uses those. And then on an array list, memory usage is less, so it stores elements in contiguous memory, whereas linked list has the extra node pointers. So those pointers are basically what distinguishes the normal array as we know it and the double linked list as we know it. And then moving on to the next question is, what is the difference between between synchronized and volatile? So this again will definitely come through quite often, but not as often, but it does come through. So you have the synchronized is used for thread safety, so allowing only one thread to access a method block at a time. So this allows when you dealing with let's say concurrency, you would basically give chance for the different threads that are running to work on or manipulate a method or a code block at a time, so that you don't have this issue of one thread manipulates the, let's say, manipulates the data, and the other one is expecting to or is retrieving the data, and then you basically are reading inconsistent or false positives, if you can put it that, because the thread that will have updated that, it's updating it because it's at that level of maybe changing the block or changing that variable for its use, and then it's going to retrieve it and use it for its own purposes, and to only find that the other thread is now reading it and writing also to it at the same time. So introducing the synchronized blocker method allows us to have that thread safety when processing during concurrency. And then volatile is ensures visibility of changes made by one thread to another thread, but does not ensure atomicity. So again, this is the flexibility that you have with concurrency. So this is to ensure your safety when working with multiple threads or having that scenario of concurrency. And then moving on to the next one is, what is the difference between checked and unchecked exceptions? So this comes along, like it comes quite a lot. You would never get tired. Basically, you will get tired of this question because everyone has to know how you handle exceptions. So you definitely need to understand and know the fundamentals of exceptions in the fundamental sense in Java, or in the context of programming. How do you handle exceptions? So let's go into that one. So checked exceptions, it's compile time. So compile time is the code will scream at you. Your IDE will scream at you if you have, let's say, your industry adopted IDEs like your Eclipse, your Spring Tool Suite, your IntelliJ, and things like that. So these check exceptions compile time must be handled using try-catch or throws, e.g. IO exceptions, SQL exceptions, if you have database exceptions, and then you also have other exceptions like your okay, let's say in this scenario, this should suffice basically. So IO exceptions, SQL exceptions. Let's see what's the other one, like object mapper. So object mapper is also one of them. Checked exceptions. You'll definitely run across that one. And then let's see on unchecked exceptions. This is now runtime exceptions. Obviously, the compiler can't check these for you because it's more on your business logic. So it basically can't tell you that this will throw a null pointer or something like that. But essentially, when you run the application and you are testing your code or running some unit tests, you basically come through these or see these exceptions coming through or being thrown. So you have your null pointer exception and you have your array index out of bounds exceptions, or like your file not found exceptions. So this can be avoided through proper logic. So this is much more on logic-based exceptions that the compiler cannot assist you with. It has to basically, the code has to be executed for them to be thrown. And that's some of them that you would have over there. And then continuing on to the next one, what are Lambda expressions in Java 8? So obviously, at this point, it's 2025. If you check Java's latest version, we are far from Java 8. We have Java 11, Java 17, Java 21, moving like crazy speed into like the latest versions of Java. But essentially, you still have most applications in the current context still uses and adopts Java 8. Also, Java 8 is an LTS, so it's on long-term support. So you definitely come across a lot of Java 8 in, let's say, maybe 2025 or things like that. But there is an adoption and traction into like the latest Java versions that are available with the modern development in the space. So please do check those out as well. So you can build from Java 8 into whatever latest spec that they define in the context of, let's say, your job spec that you came across before applying. They would give you maybe a stack. If they're gracious enough to give you the stack to say, we use Java 11, we use Java 17, we use Java 21, and things like that, you would basically still need to have that Java 8 fundamentals and then build onto that particular version that they are on, so that when they pose questions in a Java 11, Java 17 context, you would also know what comes with that. But in this case, we just want to know Lambda expressions in Java 8. And I think that should suffice if you are able to provide that, because it's not that complex. So Java Lambda expressions in Java 8 are a way to write concise and anonymous functions. So they help in writing cleaner, more readable code, especially for functional interfaces with a single abstract method. So what does this mean? So a Lambda expression essentially is a method or a function that does not have a signature. It can accept parameters and it can operate on those parameters and return a particular result. So you can basically have sum A of B, or let's do something like this. Let's see. Do I have a service here that I can quickly show you? Let me see. Yes. So here, if you look at line 25, which this is, you can see that this is basically using this variable, which is the computable future. So computable future dot when complete. So I'm saying if this computable future is done, I want it to have these two parameters, and you can see that there's result and there's an exception, and if the exception is now, log that, else throw that exception over here. And basically this is one of the Lambda expressions and how they look like. You'd come across something like this. So when complete, check these parameters and then do this operation inside this, or otherwise you can basically return a result that you expect. So this is just to show you in a nutshell how you would come across a Lambda expression. And that's about it. So let's continue into the next question. What is the difference between string builder, and string buffer? This does not come quite a lot, but you will see it here and there. It's not quite often, but yeah, you will definitely see some of these questions. So here the string is in immutable, and then that means any modification creates a new object. So if you change a string, you are basically creating a new object of the string. And then the next one is not thread safe but widely used. You're basically going to use a string everywhere, close to everywhere. And then you have slower performance due to object creation. And because of this, it's immutable. Any modification creates a new object. So slower in performance due to object creation. So every time you create a string, you're creating new objects all over the show. So that basically ends up creating more resources into memory, and that basically means more for the garbage collector when it basically executes. So that would lead to your slower performance. And then the next one is string builder. So string builder is mutable, which means modifications happen in the same object. So when you append, when you do anything, when you manipulate the string, nothing creates a new object. Everything is done in the same object, which is amazing. So it's not thread safe, so not suitable for multi-threaded environments though. So we need to consider that. And another one, it's faster than string since it doesn't create new objects. So if you have string builder, you only have one object, which is much easier to clean. You have one instance to deal with, and you get rid of it. And basically, that is one of the perks that you get with string builder. And then string buffer is mutable like string builder. It is thread safe due to synchronization, making it slower than string builder. So you have again synchronity in it. I don't know if I said that word correctly, but yeah, that's what it is. And then you have useful when multiple threads are modifying the same string. So you see the contrast between the string builder is you have one object, but the one is not thread safe and not for a multi-threaded scenario. And then the string buffer is basically mutable, thread safe, and it has the synchronization component, which then allows us to implement and use it in a multi or a concurrency scenario. You're able to modify the same string in that environment. And that's basically the three differences that you have. And then moving on to the next question, which is what is the difference between overloading and overriding? And this is a question of polymorphism. What is polymorphism? As I said earlier, this will definitely come along all the time, almost all the time. They always want to know what is overloading, what is overriding. So two differences, or let's say four differences in this case. So method overloading is you have the same method name, different parameters. So you're overloading the method, so you changing the number of parameters that are there. So let's say you have one method with two parameters. So if you have the same method name with three parameters, that is basically overloading the method. And then it happens in the same class. Return type can be different, so you can have different return types. Again, that's overloading. You can use to improve code readability. So because you have the same method name, you essentially performing the same operation, but you have different scenarios to cater for. So if I have A, B perform this operation, but I don't have C. But if I do have C perform the same operation, but in this case consider C because I do have C available. So you have optional fields. You can essentially use method overloading to cater for those scenarios. And that is, in essence, what method overloading is vastly used for. Then the next one is method overriding. So method overriding is same method name and parameters but different behavior in child classes. So method overriding is you have the same method, same parameters, same signature, same everything, but different behavior, so different implementation in the subclasses or the child classes. So each child, each subclass can have their own implementation of the parent methods implementation or parent class implementation. So it requires inheritance, happens between parent and child classes. Return type must be the same or covariant, and you also have access modifiers cannot be more restrictive. So e.g. a public method in a parent class cannot be overwritten as private in the child class. So that is basically what it means. You need to have the same method name, same signature, and you just have your own implementation in the subclass or the child class, and you basically follow those rules. And that's it for method overloading and method overriding. And we are finally at the end of the interview questions, junior developer interview questionnaire. So these are real and pragmatic questions. So please do go through them. If you have more, you can basically pop them in the comments section down below. For now, please do like and subscribe. Until next time, cheers.